Hello, welcome to this video series as we discuss human space travel and the effects on the body of either short-term or long-term space travel. We'll be discussing all the aspects of human space travel and the effects on the body. We'll talk about research that's been carried out over the many years previously and what's ongoing research. As we have concerns about long-term space travel, as we encounter possible exposure to Mars travel, which could be as long as 2 years. This is something that is unknown. So we'll be discussing this in this video series. Hope you enjoy it. My name is Juan Escobar. I'm a cardiologist with a special interest in humans in space. So let's get started. Space shuttle. For 11 years, it was a flying laboratory which allowed us to investigate the effects on human space travel. However, this was only possible for short stints of time, and with the addition of the Space Lab, it expanded the capabilities of performing research. However, this was only for short term because the space shuttle had to come back. It wasn't until the development of the International Space Station, and before that, the Skylab, that more long-term research was able to be carried out. Presently, humans have lived in the International Space Station for a length of a year. And we have twin studies, where we have twin astronauts, one who was in space for a year, and one who was in Earth for the year, and they were able to compare the effects of being in space for a year. We'll talk about this and many other aspects of research that has been carried out on the space shuttle and the International Space Station during this series. So a summary of physiologic effects of space travel are as follows. One is space sickness. It is manifest by the development of nausea and vomiting once humans are exposed to the weightless environment. It is short-lasting but can be quite uncomfortable. The next effect of space travel is fluid shifts due to the absence of microgravity. The result is that the fluid in the legs goes up to the head and upper body, resulting in skinny legs and a flushed face and upper body. After about 4 days, the fluid stabilizes and there's equalization of the upper and lower body for the remaining of the space travel. The next effect we'll talk about in space travel are visual changes. These are called spaceflight-associated neuroocular syndrome, or SANS. The cause of it is unknown, but the result is that the astronauts experience visual changes in space, which persists after return to Earth's gravity. The next effect we'll talk about is skeletal muscle atrophy and bone demineralization, which occurs due to the lack of gravity in space. The only way to combat this is to exercise. But even with that, you still lose muscle and bone, prolonged space travel, and even with short stints in space, it's been observed. The next effect we'll discuss is radiation exposure. Due to the lack of electromagnetic forces around the Earth, which are protective, as well as the atmosphere, astronauts are exposed to significant amounts of radiation in space, which only increases their exposure with prolonged space travel, and their effects are significant and unknown at this time. So this concludes this brief review of the short-term effects of space travel. I hope this gives you some insight into some of the concerns that are encountered by the astronauts. Later we'll discuss further the long-term effects of space travel. Thank you for listening.